In this section, we will look at the polar coordinate system. This is similar to the rectangular coordinate system we have been using. We will learn how to plot points and graph various types of equations, as well as how to convert from one system to the other. Hi, my name is Tom Atwater. We'll begin by defining the relationship between rectangular and polar coordinates. If a point has rectangular coordinates x, y, and polar coordinates r, theta, then these coordinates are related as follows. X is equal to r cosine theta, and y is equal to r sine theta. R is equal to the square root of x squared plus y squared, and tangent of theta is equal to y over x, where x is not equal to 0. Let's go to an example to illustrate these relationships. Plot the points in the polar coordinate system, then determine the rectangular coordinates of each point. So, the first point that we had was 2, 30 degrees. And you can see that we have clearly marked here a distance of 2 from the origin along the line that is at an angle of 30 degrees. So, what we need to do is convert that to its rectangular form. So let's take a look at what that would be, converting that to rectangular form. So what we have is 2, 30 degrees, and that's our r theta. And remember that the relationship is that x is equal to r cosine theta, and y is equal to r sine theta, and therefore we have x is equal to 2 cosine 30 degrees. Well, the cosine of 30 degrees, you'll remember, is the square root of 3 over 2. So it's 2 times square root of 3 over 2, which is the square root of 3. Now for y equals r sine theta, which would be 2 sine 30 degrees. Remembering, of course, that the sine of 30 degrees is 1/2. This would be 2 times 1/2, which is equal to 1. So our coordinates are the square root of 3, 1. Okay, well, we had a part B to that, and let's take a look at that graph right now. We have the point -4, 2 pi over 3. And we can see clearly that the angle of 2 pi over 3 brings us to a line or a vector or an angle with its terminal side here. However, the negative part of this sends us in the opposite direction, 4 units, but still following that line. So that's the point that we now want to find the rectangular coordinates for. So let's do that right now. Let's find the rectangular coordinates for the point -4, 2 pi over 3. So x is equal to r times the cosine of 2 pi over 3. Cosine of 2 pi over 3, of course, is the reference angle pi over 3. Cosine of pi over 3 would be 1/2, and cosine is negative in quadrant 2, so -1/2. -4 times -1/2 gives me +2. Y is equal to -4 sine 2 pi over 3. Well, sine is positive in quadrant 2, we still have the reference angle pi over 3. The sine of pi over 3 is the square root of 3 over 2, and therefore this is equal to -2 square roots of 3, which gives us coordinates of 2 comma -2 square roots of 3. One important difference between rectangular and polar coordinates is that a given point in the plane can have only one pair of numbers for rectangular coordinates, but the same point can have an infinite number of polar coordinates. Let's look at an example that will illustrate this. Give 3 other pairs of polar coordinates for the point P, which is 3 comma 140 degrees. Part B, determine 2 pairs of polar coordinates with R being positive for the point with rectangular coordinates -1, 1. Let's deal with part A first. Here's our point P, which is the point 3 comma 140 degrees. Now, we want to come up with 3 other points. Let's start with this positive angle here of 320 degrees. Now, it brings me to this line. And that line means that if I want to go in the opposite direction, the direction of this arrow, that I actually need to have -3 units. So -3 comma 320 degrees would give me the equivalent point. While I'm on that, let's look at -40 degrees because it brings me to the same line, which is this line along the 4th quadrant. Therefore, for -40, I also need to use -3. And so it would be -3 comma -40 degrees to give me a second equivalent point. Let me then do the other angle we have here in blue, which is -220 degrees. Interestingly enough, that brings me to the correct quadrant 2, and therefore I use +3 along with -220 degrees, and that gives me a third point, which is the equivalent of 3 comma 140. What about part B? Part B was to take the coordinates -1 comma 1, which are rectangular coordinates, and find 2 sets of polar coordinates. So to do that, we use tan theta equals y over x, which in this case is 1 over -1 or -1. We should all recognize, of course, that the point -1, 1 is over here in the 2nd quadrant. The reason that's important is we have tan theta equals -1, and it is negative in quadrant 2. Tangent of theta equaling 1 is one of the special angles, 45 degrees. So we know that we could have an angle of 135 degrees, and we could use an angle that's negative to bring us over here of -225 degrees. Well, that's good for the angles. Now we have to calculate R. Well, remember, R from our formulas is R equals the square root of x squared plus y squared. So R equals square root x squared plus y squared. So in this case, R is equal to the square root of -1 squared plus 1 squared, which is 1 plus 1, square root of 2. So we form our 2 polar coordinate points by taking the square root of 2 along with 135 degrees, and the square root of 2 along with negative 225 degrees. So those are our two that I've chosen in this case, but realize any angle that's coterminal with 135 could be used. Well, now it's time for you to try an example. Determine two pairs of polar coordinates for the point square root of 2, comma, square root of 2, with theta being greater than or equal to 0 and less than 360. Pause the video while you work on this problem, and when you are finished, restart the video to check your solution. Welcome back. Let's find out how you did on that. We have the point square root of 2, comma, square root of 2, which means the tangent of theta, which is y over x, is equal to square root of 2 over square root of 2, which is 1. Of course, this point, square root of 2, comma, square root of 2, with x and y both being positive, means that that's in the first quadrant. Therefore, theta can equal 45 degrees, but we could also use that theta, because we want it anywhere between 0 and 360, we could use that theta is equal to 225 degrees. I choose that for a particular reason, which I'll come back to when we form our polar coordinate points, but now we need to find r. R is equal to the square root of x squared, which is the square root of 2 squared, plus y squared, which is the square root of 2 squared. Square root of 2 squared is 2. The square root of 2 squared is 2. 2 plus 2 is 4. And therefore, r is equal to the square root of 4, which is 2. Now, we take that 2, combine it with the 45, and our first point that we have is 2, comma, 45 degrees. Remember I said I'd come back to why I chose 225 degrees, and here's the reason. 225 degrees puts us into quadrant 3, but we need to end up in quadrant 1. Therefore, it's going to be negative 2, comma, 225 degrees. So these are the two answers that you should have gotten when you did the pause video problem. Now let's take a look at how to graph polar equations. First, let's develop conversion equations for lines and circles. So how we do that is let's start with the line AX plus BY equals C. And now, remember that x is equal to r cosine theta and y is equal to r sine theta. And let us now solve for r, which means we factor r out from here, and we have a cosine theta plus b sine theta, and that equals c. And therefore, when we solve for r, we divide both sides by a cosine theta, b sine theta, and we get the answer r equals c divided by a cosine theta plus b sine theta. And that is the polar form of a linear equation. Well, now let's find the polar form for a circle. And a circle is x squared plus y squared equals a squared. So let's take a look. X squared plus y squared. Remember that r is equal to the square root of x squared plus y squared. Therefore, this is equal to r squared. So r squared equals a squared. And now when we take the square root of both sides, we'll get r equals plus or minus a. So that's the equation for a circle in polar form. And yes, if you're thinking ahead, you should realize that a is simply the radius. Let's look at an example where we apply these two formulas. For each rectangular equation, give its polar equation and then sketch its graph. We have y equals x minus 3, and we have x squared plus y squared is equal to 4. Let's start with part A, y equals x minus 3. The first thing I'd like to do is put that in the form of ax plus by equals c. So what I need to do is bring y to the side with x and 3 to the other side, but I'm going to start by writing this side first. So it would be x minus y equals 3. Now I can see my ax plus by equals c form where a is 1, b is -1, and c is 3. So I plug that into my formula for a linear equation, which is r equals c, which is 3, over a, which is 1, times the cosine of my angle theta, plus b, well, b is -1, so let's just change it now to negative sine of theta. And that is my polar form for the straight line. Well, let's take a look at that graph, which we have on the display. We have the two forms, the rectangular form and then the polar form. And in each case, of course, it's going to give us the straight line that we have drawn here. But in terms of r equals 3 over cosine theta minus sine theta, you can see that we've put into it the polar coordinate system with the circular graphs going out. So that's our equation and the graph of the equation in polar form for the line y equals x minus 3. All right, great. Now what we need to do is the second equation, which was x squared plus y squared equals 4. Well, that's pretty straightforward, right? Because we said that the equation for this in polar form is simply r equals plus or minus the square root of this number. So it's plus or minus 2. Let's take a look at that graph in the polar coordinate system. In either case, we have the rectangular form, x squared plus y squared equals 4. The polar form is either r equals 2 or r equals -2, and that's for all values of theta, and hence, as long as we go out 2 units, it matters not at what angle, as long as we go out the 2 units, and we'll get our circle, which is represented or representative of r equals 2. Well, we can transform polar equations to rectangular equations. Let's take a look at an example. Given the polar equation, r equals 4 divided by 1 plus sine theta, convert it to rectangular equation, and using a graphing calculator, graph the polar equation for theta between 0 and 2 pi. Then use a graphing calculator to graph the rectangular equation. All right, so first we start with the equation r is equal to 4 over 1 plus sine theta. What I'm going to do is multiply both sides by 1 plus sine theta, which will give me r plus r sine theta equals 4. Now, r sine theta is y, and r is the square root of x squared plus y squared. So we convert this to square root of x squared plus y squared plus y equals 4. I'm going to bring the y over here and make this minus y and erase that. Then I need to square both sides to eliminate the square root. Square both sides. Now on the left-hand side, it simplifies to x squared plus y squared. Square roots eliminated. On the right-hand side, we have to expand the binomial. 4 squared is 16, minus twice the product of this, so it would be minus 8y plus y squared. The y squareds cancel each other out. This, hopefully you recognize as now being a parabola, with y being the variable I would like to isolate. So, subtract 16 from both sides, and I have x squared minus 16 equals negative 8y. Divide both sides by negative 8, which I'm actually going to write it in this form. Negative 1/8 of x squared minus 16. Okay, so now let's plug that into the graphing calculator and see what our graph yields. First, we'll graph r equals 4 over 1 plus sine theta, and that's what we have right in front of us. R equals 4 over 1 plus sine theta. Looks like a parabola. And that's what we would expect, because if we now graph the parabola y equals 2 minus 1/8 x squared, you'll see that it's the same graph, which of course is exactly what we expected. Great job in today's lesson with all of the different polar coordinates and graphs. Now in this section, we learned all about the polar coordinate system. We learned how to plot points and graph various types of equations. We also learned how to convert from one system to the other. Be sure to work the exercises that your teacher assigns, and we'll see you next time.